All right, welcome back. Today we're going to go into the next lesson in the distance learning thing that we're doing right now with the given situation. And we're going to talk about how a couple new ways to find an area of a triangle. So we've known how to find area of a triangle for a long time. You know, the old kind of formula of, you might have seen it written as base times height divided by 2, or 1/2 times base times height, same thing, of course. And that's where, you literally were given the base of some random triangle and the height. You plugged it in, and that was that. But what if we don't have the base and height? What if we don't have those values? Is there another way that we can find the triangle? And the answer is yes. There's two different things that we can do. We can still find the area if we're given either two sides and the included angle, that SAS case that we talked about with the law of cosines, or if we're just given all three sides and no information about the height. Okay, so we're going to discuss both of those ways today in this video. So the first way is that SAS case. Again, if you give two sides and the included angle. I put three different formulas up there, but I want you to see that they're all the same thing. So I just drew kind of a random triangle, labeled it the exact same way that we did with the law of sines, law of cosine stuff, with the angle and the side opposite to each other. And notice I'm going to go right across the line there up on top. If I have the 1/2 BC sine A, notice the BC and the angle A, that's your side angle side case. And the same thing, if I go to the middle one, 1/2 AC sine B, again, the two sides and the included angle. And then that top angle, if I have the angle C, then I would have to have the side A and side B. Okay, so they're really all the same formula. It's just, depending on which angle you have and stuff like that is the formula that you choose. Now, I do want to go through just a real quick proof of why this works. And I'm going to use that first one, although I could have used any of the angles. So let's take a look at what this says. Notice over here on the right, I put our old formula, the 1/2 base times height. So look, if we have this triangle, C is our base. That's kind of what the base is, right? It's that, quote, bottom side or what have you. So that already becomes our base, so that's all set. But now that we know trigonometry, and of course we didn't know trigonometry back in the day when we did the old formula, but now that we know trig, we can find the height by doing our old friend the Sohcahtoa. So notice we know that sine of A is equal to that height divided by B. Well, if I just solve that for height, that becomes B sine A. And if I plug that in over there where my height is, that B sine A, then all of a sudden I can just kind of clean this up a little bit. And my area now becomes 1/2 BC sine A, which is the same thing as this. I could have done that same trick for each of these three things. I'm not going to. It works the same way, depending on which angle you're given. Excuse me. So let's go and get into an example here. This is not going to take very long, I don't think. So example one, let's say I give you angle B is 50 degrees, side A is 12, and side C is 9. So look up there, which of those formulas are you going to use? Well, I'm going to use that middle one because I got that side A, side C, and I got angle B. So this just becomes a straight old, what I call plug and chug. Okay, so you just plug in those values. 1/2 times 12 times 9 times sine of 50 degrees. You put that in your calculator and you get 41.37. Now I am going to go into Desmos. I've done this in my other videos. I'll show you how to at least plug one of these in, just make sure we're kind of all on the same page. So just plug it in, 1/2 times 12 times 9 times, of course, for the sine, we have to go down here to functions, sine of 50. And notice, sometimes it's going to give you a weird answer, so you know something's off. The area clearly cannot be a negative number. But as I've said it, many times before, make sure whatever calculator you're using is in degrees. So I'll set that here degrees, and I get my answer, and that's 41.37 if you round that off. So that's where I got that one in here too. And for all my friends that are physics teachers, I had to put my square units. I didn't give any units up here for the sides, but whether it's inches or what have you, you should put that on there. As math people, we tend to get kind of lazy with units, but they should be on there. Okay. So I'm going to go ahead and ask you to pause the video and do one on your own here. So here's the next set of givens. So your A is 22 degrees, B is 28, C is 19. So look at your formulas. Which one are you going to use? Go and pause the video and work that out real fast. Okay, so in this case, we're going to use that first one, because again, I got angle A, sides B and C. Plug it in, just how it's written, and then pop in the calculator, and you should get 99.65 square units. Again, just make sure everything's in degrees, and you should be set with that. Okay? So that's the side angle side case. So as long as you have two sides on an included angle, you can use one of those formulas to find the area. What about if you're given all three sides, but nothing about the height or no angles, or things like that? We can still find the area. And this is going to be something called Heron's formula. Now, I'm not going to prove this. The proof is a little bit longer, so I'll put a link in the description to the proof of this thing if you're interested in seeing that. But there's your formula, square root of that whole thing, that letter S. So let's talk about what an S is. S is something called the semi-perimeter, which, if you think of the name, semi-perimeter, it's just half of the perimeter. And you should remember from many years ago that you find the perimeter just by adding up all the sides. So S is just going to be the sum of the sides, A plus B plus C, divided that by 2. Okay? Whatever that number is, you're going to put that in the formula along with the A, the B, and the C, plug it in, and that's going to be your area. Now, the one thing I want to make sure and note, just in case you have, you get a case of kind of careless fingers when you're doing the calculator or something like that. When you find S is always going to be larger than any of the sides. Okay, so just make sure and keep that in mind and kind of keep an eye on that S value. So let's take a look at an example here. So my first example is if you're given three sides, 6, 17, and 19, the first thing you got to do is find that S, right? So S in this case is 6 plus 17 plus 19, that whole sum divided by 2. And in this case, you get 21. Remember, sometimes you might get something 0.5, you might get a decimal there, that's okay. But once you find S, now we can find the area. And again, it's a plug and chug, right? So we just put in the square root of 21. Don't forget that S does come first right here, right? So you got whatever the S value is, and then times S minus A, S minus B, and S minus C. And again, you just plug that in the calculator, let the calculator do all the work for you, and you should get that. And I'll go and type this in here for you real fast in the Desmos again, just so you can see it kind of in action. So the first thing I'll do is I'll go and find my S value. So that's, let's see, 6 plus 17 plus 19, all divided by 2. And you get 21, so that's my S value. And then to find the area, square root 21 times 21 minus 6. And then 21 minus 17, and then 21 minus 19, and you just hit enter, and you see what the answer is already, I rounded that up to 50.20 instead of 50.199, and that's kind of what that answer is. Okay, so that's where we get the area for that. So again, both of these formulas are just kind of plug and chug stuff. I do have one more example. I'll have you pause the video again and work on one on your own. So there's your three sides, 22, 14, and 17. I'll give you a few minutes and we'll go through the answer here in about 5 seconds. Okay, so again, the first thing you got to do, if you're given all three sides, the first thing you got to do is find that semi-perimeter, find that S value. Add those up together. In this case, you do get a decimal, 26.5. It's fine. But then whatever that S is, you just plug it in. So you find the area, plug all that stuff in there at one time, let the calculator do all the work. Just make sure you're putting it in correctly, of course. And you should get, I could have rounded that up to 119 even. So I wrote it as 118.999. That's actually what it came out to be. But you can certainly round that up to 119. Okay, so that's it for today. There is going to be a short assignment on Classroom on finding area. I kind of mixed the problems up together, but again, if you're given the side angle side, you're going to use one of those three formulas depending on what you have. If you're given all three sides, that's where Heron's formula will come in. Okay, down in the description, I will put I'll put a link to Desmos. I'm sure you're using that already, or if you have your own calculator. And I'll also put a link to the proof of Heron's formula if you're interested in seeing that. Okay. I hope you found the video helpful. Good luck in all you're doing. If you have any questions, feel free to email either myself or whoever your teacher is. Feel free to share the video if you have anybody else going through the same thing. And of course, feel free to subscribe to the channel if you would if you'd like to see some more videos as I put them up. Have a great day. Enjoy the rest of your weekend, and we will talk to you soon. Keep studying.